Yeah, thank you for the recording. So yeah, I think this is week 4. You remember correct. So yeah, welcome back to the DeCal, and we're gonna be covering some more stuff today, basically. Very useful stuff. You would use this every day from now on. Yeah, whenever you're coding. Right, let's get started. Some announcement. Second homework was just due. Was it the second homework? Yeah, that was the second homework. Office hour. I think I just ditched one of the office hours. But yeah, for thank you for everyone who showed up for like other people's office hour. Keep coming to the office hours if you have questions and stuff. Attendance, here's the form that James has sent into the chat. And if you are watching this remote, if you're watching this at some other time, please fill it in as well. Yeah, so some recap for what we did last week. So yeah, 7 days ago. So there are 2 questions. First one is what is a recursion? The other one is how are dictionaries different from lists? I think that's all the questions that we have. Yes. Wait, how did I go back? Sorry. So as usual, we're gonna put you guys into breakout rooms and yeah, and have like what? And yeah, so that you guys can discuss it. How many people do we have to do it? I'm sorry, but now that we're all applying to grad school next semester.
I'm not. I got a year, baby. Fall 2022. That's my last semester. I'm taking an extra one.
Oh. One fewer competitor. Great.
Yep. One can say the same, Elon. I'm really trying to avoid your idea. I don't think I can stand against you.
Okay, I'm quitting astronomy.
Good.
Save it for right, so everyone is back. And yeah, so who wants to answer the first question? I mean, yeah, if no one volunteers, we're gonna call out people, so you better volunteer.
Jeez, you can't be like that. You just gotta ask politely.
Well, people will get used to it. Really? So we're gonna call out people for those who don't turn their camera on. Oh, someone wants to volunteer. Yeah, Megan.
A recursion is a function that calls a function repeatedly on itself.
Yeah, basically that's it. Which no one uses. But
that's not true. That's not true at all. But okay.
But yeah, sorry. But yeah, so you don't really use recursion very often, but I mean, like, it's a useful tool, I guess. So that's the official answer. But I don't use it, so no one uses it. Yeah. So yeah. And how are dictionaries different from lists? Anyone?
From what I know, I think the main difference is that lists have like orders and dictionaries are more like a group and you can like, they have like keys.
Right, yeah. So yeah, so those are the 2. I mean, you mentioned two points of differences, right? So like the first one is like list does have order and dictionary doesn't. So every time you call a dictionary, it might be a little bit different. It might be like shuffled. And also the second feature of dictionary is that you can call keys, and then so it's like what I think of it as like list within the list, right? But like you can call the list by name. So yeah, but dictionaries are useful. They're very useful. Now I sort of like have it in all my code at some point. So yeah, but what's even more commonly used than like recursion and dictionaries are what we're going to be talking about today, which is a tool that will make your code much more powerful than what you have at this point. Yeah, so in general, how to make your code more powerful is basically you have like all this, you import packages. So packages are basically a whole bunch of code that people has written already, and then they are they are publicly available online. And then you just import it into your into Python, and then you can just use whatever the functionalities like those packages have. So when you installed Anaconda, all those packages come within onto your computer, so you can just do like that. So in general, the way we import a package is to use this import statement, and then where it's literally just import, and then you import space, and then you put like the name of your package over there. Say like before we imported this math package before, but there are also like import this package called random and import numpy. Numpy is like a very powerful tool that we're going to be covering today, basically. Yeah, so basically, like I said before, you don't have to write your own functions. So like say for example, standard deviation, right? Standard deviation, you don't have to write it. I mean, it's a very complicated summation, right? I mean, it's like, yeah, it's a difference squared over some average. Yeah, something like that. But you don't have to write it anymore. Like there is a function that you can just use straight away. And yeah, but then again, I mean, even for standard deviation, there is a formula, but for median, to find the median value of like 100 numbers, there is no set formula for you to find it. Like you just know it's the number in the middle, and that's it, right? So but packages can do this straight away. Like it just picks out the one in the middle, and then you don't have to write your own code. It's like one line, and then you will get your output. You will see what I mean, like as we go on. Why is this not working? Yeah, so like we said, import. So it's a package to import package name, and then as alias. This alias is optional. So if like some package name has a really long name, you can like you can make it shorter. Like you can create your own name for it, right? Like what we're gonna be doing today later. So yeah, so we're going to be talking about numpy, and then for numpy, what you're going to be doing is like you import numpy as np, because you don't want to like type numpy every single time. That's just redundant, right? So we abbreviate it into like this np thing. So it's like setting the package name into a variable. It's like analogous to that. Yeah, and in general, you do put this import statement at the very beginning of your code, but you don't have to. But like remember, Python runs like sequentially. So like if you run it up, if you put it at the very beginning, then all your code can use this numpy, right? This numpy package. Right. So what NumPy can really do is like one of the most common feature of NumPy is this thing called array. And it's literally the most used tool in science. Like everyone uses it because it's just so convenient, right? So so here's a list that we talked about our very first lecture, where it's a list of like integers starting from 0 to 7. But then there's another NumPy array, which is basically you literally do NumPy dot array, and then within the parentheses you put this list in, right? But how are they different, right? I mean, like except for like this NumPy dot array thing, right? Like so, because apparently those are two different objects. Those are two different types of objects. So if you do type L, then you will get a list. If you do type array, you will get like a NumPy ND array or whatever. So yeah, so how are they different? Except for the fact that they do use the same indexing rules, the 0. So the first one is the 0th element, the second one is the first element, etc., etc., etc. But then NumPy array is actually superior because let's do some review first before I actually introduce you to this. So we have two lists of like this two same lists, right? So say for example, if I do this 3 multiplied by list 1, what's going to be the output? Anyone remembers? or like list 1 plus list 2, which either one is fine. I mean, like
List 1 plus list 2 is just gonna like add it to the end.
exactly.
I'm not sure about the first one. 3 times list 1. I guess it'll just multiply each component by 3.
Nope.
Oh, okay.
Three multiplied by list. Sorry, yeah. Who was it?
It would print list 1 3 times.
Right. Yeah. So you will have like it won't print out the list 3 times. It will like join 3 identical lists back like that together. So it will get 0 to 7, 0 to 7, 0 to 7 in a single list. So it's like addition, right? But then when you have 2 NumPy arrays, so these are what we call 1D array because you only have 1 list in it. Those are 1D. So if you do 3 multiplied by array 1, then is what Russell said. You multiply each element by 3. So it goes into like these mathematical operations. It goes into each element instead of acting on the entire list. Does that make sense? So and then if you do array 1 plus array 2, it'll add up the 2 arrays element wise. So the zeros element will add with the zeros element, the first element added to the first element. So that's why we got 0, 2, 4, 6, 8, 10, 12, 14, right? In this array 1 plus array 2. Does that make sense? So like you don't have to do like a for loop to add them together, right? If you had 2 lists, you would have done like a for loop and then add them together to get a new list. But now if you have 2 arrays, you can just do a mathematical operation and then add the 2 arrays together, and everything will be added element wise. Yeah, and this only works if the size of the 2 arrays or like the length of the 2 arrays are the same. So if you have an array of length 3 and another array of length 2, right? If you add them together, that's not gonna work because one of the arrays is missing an element, right? So that's gonna give you an error. Yeah. Does that make sense? Right. So any mathematical operation acting on an array, it always always acts element-wise. So if I do if I do like array squared, right? Array star 2, then everything in the array will be squared. And then if you do 2 star array, then in the output array, it'll be like 2 to each element, right? I mean, I can show you this later if this sounds like too abstract. But yeah, but this is by far the most important thing in this DeCal. Everything else we talked about before was useless. So you just have to remember this. That's it. Any question? Good. Yeah. So what else we can do with 1D array? So for example, we can calculate a mean and average value. We don't have to write this code on our own, right? We don't like we said before, is this sum of like the list, right? Divided by the length of the list, which is basically how you calculate the average of some data. But now you can just do numpy.mean and then put in your array, and it'll calculate the mean for you. It's like you don't have to like you don't have to use your brain. Literally, just put in like mean, and then it'll give you the mean. And also same for standard deviation, right? Yeah. So like 2 years ago, I used to call standard deviation San Diego. So yeah. So this numpy, there's this function called numpy.std, and then you put your array. It'll calculate the standard deviation for you. According to some standard deviation formula. It may not necessarily be the standard deviation you use, but most likely it will be the case. Like the difference will be like super small, especially if you have a large population. And then you can also calculate a percentile, right? I mean, percentile is like sort of like a hard thing to calculate. Like so you have to find like what's the 16.8 percentile of a population. I mean, like to write a code. I mean, I don't know how to write it analytically, but like with NumPy, you could write numpy dot percentile and then put in your array, and then put another percentile, like whatever the percentile you want to calculate, and then it'll output it straight away. And then same for the median value, numpy dot median, it'll output the median value directly instead of like you writing your own code to like get a stupid median value. And these are basically functions. So whatever that goes into it are the arguments. So and they work sort of basically the same as the function that you would write, right? So if you write like the def function and with parentheses and with some argument in it, this is the same thing. It's just like other people has written the function for you already, and you can just use it directly. Wait, do I have like questions there? Oh, there's no question in the chat today. And then so except for a 1D array, we also have 2D arrays, and these are in some sense equally commonly used as the 1D arrays in science. Actually, is sometimes even more, because 2D arrays, especially in astronomy, that's how we store our data, because all our data are images, and images is a 2D object, right? You have like length, you have a width. Sorry, you have height, you have a width, and then it has a bunch of pixels put together, and each pixel is assigned a number, and that's basically a 2D array. You can think of it as a matrix as well. So a 2D array would be something like this: numpy.array, and then within the list you have two more lists, so 1, 2, and 2, 1, and then mathematically this is basically the matrix that we show on the right, is 1, 2, 2, 1 matrix. So those two things are equivalent. So, and you can also store like different informations in the 2D array. Say, for example, like you have like this, if you have some X values, have some Y values. Oh, it's missing something here. Whatever, yeah. So sorry. So yeah, so you have some X values of the data and you have some Y values of the data. I can store them in the same array, right? And then I can pull them out somehow if I want. There is missing a square bracket and the parenthesis on here. And like I said before, like astronomical data set are 2D arrays, basically, especially the original data that you may work at some point. Yeah, so those are just some examples that the data that I've used. Like for example, like this spectrum is a 2D array. So yeah, each pixel is given a number. It's given a number, and then it generates the data. Yeah, and for slicing and indexing, this is a little bit confusing, I guess. And so, say for example, how does this work, right? So we know indexing in 1D array and list. Basically, it's basically given by a number like 0 to n, right? Where n is the length of an array or length of a list. But for 2D array, it's slightly different, because 2D array has like two axes. Axis 0, which is the vertical one, which goes vertically, but it counts the row, right? So axis 0 counts the row, axis 1 counts the column. So I have the array over here, and then this is the equivalent matrix for that. So, and also you can have more axes as well. So like you have like, so you have like some tensor, which is like a box, a 3x3, sorry, a 3D array, 4D array. Things works differently. We'll just take 2D array as an example. Okay, so this is how it works. So I have this array over here, this matrix. And then if I call array, so a 2D array, to call an element is signified by two numbers, right? Because the position of any element in this array need to are specified by two numbers, column and row, right? Like a matrix. So like a matrix, like Aij, like that Ij is like the row and column, right? So this is the same thing. So for array, you give it two numbers separated by a comma, and then so first one, sorry, the first number is the index along the axis 0, which is the row. It's giving you which row is this element in. And the second number, which is like here, like I boxed out, like in the orange box here. And then I have this 2, which is telling you which column this element is in. And then there's only one intersection for these two, for this row and this column, right? Which is the number 3 over here, and that's why it output me the 3 as the output of this operation. And then there's also this column thing that we talked about before, which is basically saying I want everything along an axis, right? So I want everything. So if I do array colon comma 2, then that's gonna give me all the rows. So it's gonna select all the rows, but only the second column, which is 3, 3, 1. That's why it outputs the 3, 3, 1 array. Yeah. So say for example, if I want a middle row, the middle row here, what would be the index? Anyone?
Would it be 1, colon?
Why?
Because it's the like row 1 and then all the columns.
Exactly. That's what we want. So like the colon is basically, it wants everything along an axis. Although these axes are a little bit confusing, but really you can, for a 2D array, which is more commonly used, you can just think of like the first number being counting the row, second one being counting the column, and then the colons are used for getting everything along the axis. Yeah, nice, Rob. Yeah, so there are also axis-wise operations. These are some weird things. So like we said before, for a 1D array, you can do numpy.mean and then calculate the mean of the entire array, of the entire like this 1D array, right? But then if you have like multiple lines of data, right? Say for example, if I measure the resistance of some resistor, right? For each resistor, I measure 3 times, and I have 10 resistors, and I want the average values of all of those, average values of each resistor over the 3 trials that we make, right? I mean, how do we do that? I mean, but if you do the numpy array, if you do numpy.mean on the entire array, say for example, this array, it's gonna give you the mean of all 9 numbers in it, instead of like a certain row or a certain column. So how does that work? So, but if you only want, say for example, this 1, 2, 3, the does that make sense? Yes. Yeah. So if I only want, the the average along a certain axis, or along a certain axis, say for example a certain row or a certain column, then how are we gonna do that? So this is how it works. So we have like this numpy.mean, right? We have this numpy.mean, and it is same as before. We input our array, and then we specify which axis, along which axis we want to calculate our mean. So this, say for example, I specify axis 0. That means it's gonna calculate the mean along axis 0. So 1, 2, 3, 2, 1, 3. Sorry, not the. Sorry, I messed up. So it's gonna calculate the mean for each column. So it's gonna calculate the mean over the axis. Does that make sense? It's gonna calculate the mean along the axis. So if I specify axis 0, it's gonna give me like 1 plus 2 plus 3 divided by 3, which is 2. 2 plus 1 plus 2 divided by 3, which is 1.67. Does that make sense? It's gonna calculate the mean of each column. And then if I do, say for example, if I do the mean if I do mean array axis equals 1, it's gonna calculate the mean along or over axis 1. So it's gonna calculate the mean of each row. This is confusing. Sorry, I had to do my mental math before. Does that make sense? There is no easy way to remember this, but there is an easy way to do this, which is try and error, because you only have 2 axes anyways. You know which one is which. So you just try, and then some axis will work. And then similar for this median thing. So the median, when it's a number, the median array, and then along axis 1, then that means we're finding the median along axis 1, which is so we're finding the median for each row, right? So which are like 2 in this specific array. Yeah. So does that make sense? Yes, no. I think that's fine. Wait, there are more in the chat. Yes, for Ralph. So Ralph was asking, like, is the up and down axis always 0 and the other one is always 1? Yes. So this 0 and 1 are set. So yeah, this vertical axis, the one that counting row is always axis 0. The other one is always axis 1. For if you have a 3D array, which is like it's like a cube, right? If you think of it, 1D array is a line, 2D array is a matrix, 3D array is a tensor, which is a cube. Then you may have to try and error. 0, 1, 2. It just adds an additional axis in it. I mean, I can't draw it here, right? But I guess you see what I mean. Yeah. So sorry. So axis 0 in that case would be for each matrix, right? Axis 0 in that case would be each matrix, and then axis 1 is the vertical one. Axis 2 is the horizontal one. Yeah. Yeah. So Carlin also had another question. Do the pairs in bracket represent the rows? Sorry, I was not checking this earlier. Do the pairs in brackets represent the rows or the columns?
It was from a while back, but I realized just when you were putting things together, like listing, sets of brackets, those are listing rows, not columns.
Oh, these ones?
No, it was even before that, I think.
Oh.
Yeah, like that, like 1, 2, 3, comma 2, 1, 3, comma. Those are the rows.
Right. Yeah, those are rows. Yeah. Yeah, but sometimes a little bit tricky especially if you want to have like a vector, right? Which is like which mathematically is a 3x1 matrix, but sometimes you can use a 1D array. Yeah. You don't have to use like a 2D array in that case. But yeah, one like the 3D vector is a little bit weird, but in general, this is a row. Yeah. All right, so let's do some demo. All right, if there's no more question, let's do some demo. So again, we use Jupyter Notebook, and let me share the screen. So again, in Jupyter Notebook, the first thing, for any of the coding practices, basically you import the packages that you use. Like in this case, it's import NumPy, right? But we wouldn't want to type NumPy every single time, so that's why we use NumPy. So that's why we use NumPy as NP, right? So you run it, and then now we have the package imported. So let's create an array first. So array 1 equals numpy array with the parentheses. Within the parentheses, you have a list, right? So I can do 1, 2, 3, 4, 5, 6, 7. I can do another array, array 2, which would be, let's do some fun stuff, 1, right? And then if I add them together, it's gonna like each element is gonna add to the corresponding element. So we get 3, 5, 7, 9, etc., 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 right? And then same thing if this was a minus sign, right? And then if this was like a multiplication, that works as well. If that was a division, that also works, right? And you can also do exponents, exponentials, right? So that's going to be it's going to give you 1 to the power 1 squared, 2 cubed, 3 to the power 4, 4 to the power 5, etc., etc. See, it just goes on like that. You can also multiply the array by a constant. Array 1, like we said before, every single element will multiply by the constant. You can, well, same for division. You can also add a constant, then everything will be added by like this constant. You can square the entire array, and then it's gonna square the entire element. You can also use the array as the exponent, and then on some number, act it on some number, and then it'll give you the array. Yeah, so these are the element wise of an array. The indexing are the same. So for like array 1, if I do index 1, it's going to give me the first element, which is 2 here. So it's going to give me 2, right? I mean, index -1, that also works as well. I think we talked about it when we talked about like indexing of lists, right? -1 also works, which is the element at the very end of the array. It's going to give me 7. And for those mean values and standard deviation, we can just do numpy dot mean, and then we'll put in the array. And then, because this is a 1D array, we don't really have to specify the axes. So we can just run it, and then it'll give me 4, right? Which happen to be the median value of this array as well, right? So, and also 2, whatever. Oh, great. Yeah. And we can also find the standard deviation, like we said before. numpy.std. We can do array 1, and then it'll give me that the standard deviation of this array is 2, right? Yeah. So what else? Yeah. So let's work with an 2D array. For percentile is going to give me array 1, and then it's going to give say the 68 percentile of this array is like 5.08. I mean, like, you see, like, you don't have to write your own code. You don't have to write your own functions for this. Like, you can just use it straight away, right? For a 2D array though, actually, you know what? I'm gonna do this. Array. So 1, 2, 3. 1, 2, 3, and then 1, 2, 3. 1, 2, 3. So this is a 3x3 matrix, which is a 2D array. And then I will do the same, but maybe multiply. Array 2 equals 2 times array 1. So this means like the thing that we talked about, this element-wise operation also works for like any arrays of any dimension, right? So if I do 2 multiplied by array, every single element in this 2D array, all those non-numbers are going to be doubled. And then if I call array 2, you can see that every single element is indeed doubled, right? I mean, and this also works. Like addition, multiplication, all those mathematical operations also works in this way, element-wise. And also we have, well, what else do we have? We have like, let me show you this slicing, this axis thing. So if I want to call the first row, let's do this so that you know it's the first row. So if I want to do the, if I want to do the, if I want to color the first row, right? Or I will do array 1, and then first row is going to be 0, and then column, because this one, the first number in the indexing is the row, right? It's the row numerals, and then the other one is this column is saying I want the entire row. So that's what. So that what's gonna give me is 1, 2, 3, right? Which is the first row over here. If I want a second row, I can do 1, right? Which is 2, 2, 2. 2, 2, 3. If I just want to call out, just want to like pick out the 3 in the like this 3 over here that I highlighted in the array, I will do array 1. And then if I count the row, so this is 0, 1, 2. It's gonna give me, it's on the second row, and it's the on the first column. So it's gonna be 0, right? So it's 3 over here. It's gonna give me the 3. So these are the slicing of an array. And if I want to pick out like the last column, right, I can do array 1. I want the entire, I want everything along this axis, and then I can do the last column, which is -1, right? You can also do 2. I mean, these two are equivalent. So array column -1 and array 2 are equivalent in our case. And then like we said before, this let me delete some of the things so you can still see it, right? So if I do numpy min of array 1 without the axis argument, it's going to give me one single number, which is the average of all 9 values. But say if I add the axis over there, the axis argument, say if I want everything, the mean for each column is going to be along axis 0, which is along each row. It's going to give me 2, 2, 3. And if I do mean array 1 axis equals 1, which means I want the mean along axis 1, which is the mean of each row, it's going to give me 2, whatever this is, right? This number is. Same thing for median and standard deviation, right? Array 1, 0. In this case, they're the same, but let's say standard deviation, right? I mean, if you do axis 0 for each row, for each column, it's going to give me the standard deviation of those. And then if you do axis 1, it's going to be a different number. Yeah. So, any questions? I mean, arrays are fun. Like, you guys should like master it. And they're very useful and very important. Yeah, so I think we're a little bit early, but I think that's all we have today. So yeah, you guys